Hello students, in this video we'll see how to solve problem 3.3.109. Problem 3.3.109 asks us to solve the differential equation y times y prime equals t. It's important to understand the context of this problem. In the context of this problem, y is the dependent variable, since we see a y prime term. Therefore, y prime will be dy dt, as t is the independent variable in the problem. So our final answer should involve y's, t's, and a constant of integration. So returning to the problem, we write this as y dy dt equals t, and we can algebraically rearrange this equation since it's of separable form. By multiplying both sides by dt, I have y dy is equal to t dt. I've separated the y's and the t's, so now we will integrate both sides of the equation. The integral of y dy is y squared over 2. The integral of t dt is t squared over 2. And I put a constant of integration on either side of the equation, so I'll put a plus c over here. And we can therefore say that y squared over 2 minus t squared over 2 equals c is the solution of our differential equation. And I have a one-parameter family of these solutions. This c is an arbitrary constant. This is a one-parameter family of curves. Alternatively, we could have noticed from the outset that y prime is the derivative with respect to t of y squared over 2. And to see that, we will use the chain rule. So the chain rule will tell us that this will be y times dy dt. So in fact, this is true. So our differential equation could have been written as the derivative with respect to t of y squared over 2 is equal to t. And now this is an even easier equation. We can simply just integrate both sides, and we will get y squared over 2 is equal to t squared over 2 plus c, which is exactly what we found from the previous method of separation of variables. In further sections, we'll see this technique is known as the technique of substitution, and it's also a very powerful tool to solve differential equations of first order. Thank you very much.